So this is the final question of the 2014 mock exam for distributions for Lincoln High School. It is question 3C. For another farmer, the number of fleeces rejected from a certain batch follows a binomial distribution with mean and standard deviation 3.38 and 1.79 respectively. So respectively just means in that order. Doesn't mean we're showing it some respect. It means in that order. So I'm going to write that down as I go. So mean mu equals 3.38. I'm being naughty using red here. Don't use red in the exam. They don't like it. The markers hold the red pen and also the green pen. So standard deviation sigma equals 1.79. Okay. Now the verbs. What are we being told to do? Calculate the probability that less than 4 or more than 6 fleeces are rejected from this batch. Show your working, another verb, and explain, another verb, what you are calculating at each stage. So I'm going to highlight all those verbs, because they're the things where you get marks, and they're the things that you miss out on if you don't read the question properly. Okay, so how do we get started here? A good place to get started is say, what's one thing we know? Okay, well, one thing we know. Now you can pause the video and write some things down. So one thing we know is we know the mean and we know the standard deviation. Another thing we know is that it's the binomial distribution. I know I've got to use binomial. Normally when I use binomial, I need two parameters. What are those parameters? You need to know what the parameters are. They are the number of trials and the probability of success in each individual trial. Do we know the number of trials? No. Some people made the mistake of assuming it was 50 because the question before had 50 fleeces in a batch, but you didn't read the question properly. Notice it says for another farmer and a certain batch, this batch. So we can't assume it's the same batch. Don't assume it's the same batch unless they tell you it's the same batch. We don't know how many fleeces there are in this batch. Probability that an individual fleece is rejected from this batch, different farms, so we don't know what that is either. Okay, how can we work it out? Well, what do we know? We know the mean and we know the standard deviation. Let's have a wee look at our formula sheet for the binomial distribution and see if that can shed some light on that situation for us. So formula sheet out, please. Here it is, so binomial page. Notice that at the top of the page, there's some formulas. And if you look really closely, so we're told the mean, mu, equals n pi, and the standard deviation, we're told, is square root of n pi 1 minus pi. Now pi is just the same as p. Pi is actually the Greek letter for p. So it's got nothing to do with 3.14. No matter how many decimal places you know it, that ain't going to help you here. Pi means p. So in this case, p's can be pi's. Okay, so the mean is np. Now that kind of makes sense when you think about it, because it's like if you were throwing 100 coins, okay, and you asked what's the average number of tails you would expect to get out of 100, you would tell me 50. And you can get 50 by going number of trials, 100 coins, 100 times 0.5 is 50. So the number of trials times the probability of success in each individual trial is what we expect the mean to be. Standard deviation is can be derived as well, but that's beyond the scope of this course. But it's there, you can use it, sub the numbers in. So let's write these formulas down on our paper. So next step. Okay, so mean equals, and I'm going to call it P because I'm used to calling it P. Okay. And standard deviation equals NP 1 minus P with a big square root veranda over the top of it. Keep the rain out. Okay, so now let's see what we can do with that. Well, we know the mean is 3.38. So we're going to whack that in. So NP equals 3.38. And over here, whoops. So I'm going to sub in standard deviation part. I'm going to whack that in into this formula. So NP 1 minus P square rooted equals 1.79. Which of course means that if I get rid of the veranda, if I take the square of both sides, NP1 minus P, that means I've got a square 1.79. I'm not going to evaluate that yet because it's going to be a messy decimal number. What I am going to do though is something else that might help me. Notice that NP is part of this formula as well. So I can actually substitute that in here. So it's just like a simultaneous equation that you did back in Mat 101. Okay, so that means that part there is just going to be 3.38 times 1 minus P equals 1.79 squared. 1.79 squared. Okay, so now I've got two pieces of information. What can I do with that? Well, I can work out what P is first, can't I? So which equation has two unknowns in it, folks? This one has two unknowns. There's N and P, so we can't really work with that. What about this one? This only has one unknown. And I'm happy because that means I can solve it. It's just an equation with an unknown in it. So let's solve for P. Once we know what P is, we've got our P, we can sub our P into the other formula to find out N. So have a go from here yourself. Pause it, and if you can get it from here, just check your answer, and you don't need to listen to me anymore. Otherwise, I'm going to keep going. Okay, so just unwrapping this. So it's 3.38 times 1 minus P. I will evaluate it now. So it's 3.2041. Okay, now let's get rid of the brackets. So 3.38 times 1 minus 3.38 times P equals 3.2041. Now I want to make P the subject. So you can do that however way you like. I'm going to skip a few steps. So I'm just going to go 3.38p equals 3.38, take away 3.2041, which equals 0.1759. Okay, and dividing both sides by 3.38, we get P. So P, the probability of an individual fleece being rejected, is 0.052014. Now, I don't want to round that number yet because I'm still using it for another calculation. So what I'm going to do is I'm going to save it on my calculator. The way I do that is I go right arrow, and then I go alpha, and then I go A, and then I go execute. And that's going to save it as directory A on my calculator. Like so. And that means that I can recall it. I can go, if I go alpha A, and then I go execute, see that number's restored there now, so that's good. So now I can round it a little bit here. I'm just going to go 0.05204, 0.5204, dot, 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 just to tell the examiner I haven't rounded it yet. Okay, so now I'm going to sub that back into my other formula up here to find out the number of trials. Okay, so NP equals 3.38. So 0.05204. We already know P, but we don't know N. Okay, so dividing it, and we should find our N value. So N equals 3.38 divided by that, like so. Grab our calculator. 3.38 divided by, and since I've saved it as A, just go divided by alpha A. That's the unrounded version. Execute. And we get 64.948. So 64.948. Now, hold on, let's actually think about the context. What's N mean? N must be the number of fleeces in a batch, mustn't it? If you've done the previous question, that'll help you with that one. Number of fleeces in a batch, and it was 50 in the last batch. So we can't have 64.9 of a fleece, so that means we're going to round it. Therefore, N equals 65 fleeces in a batch, like so. So the probability that each batch can take, well, the probability that an individual fleece is rejected is this, and so 0.05204, and then there's 65 fleeces in a batch. So now we can just turn it into an achieved binomial question, calculate the probability that less than 4 or more than 6 fleeces are rejected from this batch. Now, when you asked to do a binomial probability, always do your number line. So 0, 1, 2, 3. And what did it go up to? We're not going to write it all the way up to 65, but we don't need to. We just need around the 4 and 6 mark so we can picture what's going on. 5, 6, 7, 8, 9 up to 50. Sorry, up to 65. Okay, and less than 4 or more than 6. So I'm going to highlight less than 4, so that's 3 or less, or more than 6, so 7 or more. Okay, what's the fastest way to work this one out? Well, the fastest way is to work out the part you don't want and subtract it from 1. The part we don't want is this bit in here. The way we're going to work that out is we're going to find the probability of 6 or less, because our calculator, remember, does x or less, doesn't it? And then we're going to subtract from that the probability of 3 or less. Okay, so let's write that down first. So probability that x is less than 4, or x is more than 6 equals 1 minus the green bit. And the green bit is the probability that x is 4 through to 6 inclusive. So that's going to be 1 minus, in brackets, so it's going to be the probability that x is less than or equal to 6 minus probability that x is less than or equal to 3. So I'm going to work that, the sum of those two, and subtract it from 1. So you can do it from here. Remember that CD on your calculator is what you're going to be using. So stat, distributions, binomial, and B CD, because it's a range of values. Make sure it's on variable. And I want 6. So 6 or less for a start. Number of trials is 65. Probability I've got saved. So if I go recall A, it spits out that there. I'll show you. Recall A, execute. Okay, so I don't have to worry about rounding. And then that gives me this number here, 0.948, etc. And okay. And then I need to also subtract from that the probability of x being less than or equal to 3. So that 0.55992285, which equals 1 minus the answer to that, the part in brackets. So 1 minus 0.388, etc. And we get 0.6116 for significant figures. So let's have a look at the marking schedule. Okay, so final question here, and it says, yep, works out the probability of success in each trial, the number of trials, gets these probabilities, and ends up with 0.6116. For excellence, correct calculation of combined probability with full explanation of working. Merit partial credit as if you get as far as either of the parameters, N or P. Well done. To practice more of these, you're actually just best to work through things like the D&D resources book, or ask your teacher for an extension, some extension questions. I have some that I can give you if you come and see me. All the best.